now.
That's good.
Come on. Do you know how to be a director? You say lights,
Oh, lights.
camera.
Camera. Action.
Okay, let's try it again.
Lights, camera, action.
All right. Okay, so let's say f of x is equal to 3x squared plus 6x plus 4, and I say estimate the slope at x equal -2. How would you do that, Will? You would use what?
Use.
How would you do this? I give you a function, I say estimate the slope at x equal -2.
We're going to do the.
Give me a word.
The delta x and the.
We would use what tool? Excel. And we would make a what?
Graph. A table.
Okay. And then we would look, if I just tell you to look at one point, what would you do?
Go from a
To
little above and go below.
Right.
1.9, 2.1.
Yeah, and then if I don't tell you anything, you know that you kind of start at like 1.9 and 2.1, and then what? 1.99, 2.01, 1.999, 2.001. And so like Noah usually say, well, you would say, well, what's the delta x? But if I give you a problem like this, you just you go on both sides and you squeeze down on it, okay? And then you squeeze into an answer. And then you print out that and you attach it. Don't just answer it. You know, you've got to print it out and you've got to answer it, okay?
So are we doing just like a chapter test? Or are we doing, because we took that test over all the Excel stuff.
This is a test that will include the Excel stuff, okay? Because I just gave you an Excel problem.
Yeah, I just didn't know if we did that.
Okay, thank you for asking. I'm not trying to, I didn't mean to be sarcastic. I'm just saying, right, there will be Excel on the test and you'll be doing slopes, right? The slopes will be included, and then slopes, and we're doing limits, okay? So what if I said, estimate the slope of sine of x, okay, the slope at x equal pi over 4. You would do the same thing. You would do what? Squeeze in around pi over 4. All right. Now, what you have to make sure is that you know your functions. And so, like if I say find the slope of ln of x, in Excel, you better make sure that you know how to what? ln. And there's a difference between ln and what? lg. So you better know which one to use to get the ln and not the log, or how to get the log and not the ln. Do you understand what I'm saying? Okay, so who needs to know how to type the function into Excel?
Yes.
And you better know which two different functions.
The ln and the function.
Log and ln, which command is which. And then you better also know that if you're working in Excel, whether Excel is working in watts or whatts, radians or degrees. And if I give you a problem that is in degrees and Excel uses radians, then you better convert your problem to radians. Does that make sense? Any questions on that? Okay. Okay, Will, tell me about the limit as x approaches -1. I mean, tell me different things. Don't just tell me the answer. Tell me the different parts of the answer.
That is discontinuous.
It's discontinuous. Okay, what else?
As it comes from the right, it's.
So we would say that's the, don't say that. Tell me in words, limit of what?
Limit of x goes to
Limit of
-1.
what?
limit as x
Oh, okay, limit as x goes to,
-1 from the left
okay, of what?
of f of x, whatever that is.
Yeah, f of x, and that's equal to what?
1.
1. Okay, tell me something else.
And you can go the other way as it goes to -1 from the right.
Tell me in words. I mean, tell me what
As
direction.
x goes to -1 from the right.
From the right? Is that how I do it?
Positive
Okay, that's what I'm trying to get you to say. Okay, of what?
f of x is -2.
And then what do you say? What else?
The limit.
What?
Oh, the limit as x approaches -1 of f of x does not exist.
Does not exist. Okay, what's another very important concept? So we'll answer everything about the limit. What's another very important concept on a problem like this?
Jump discontinuity.
It is, but what do you have to think about before you say that? What's a very important concept?
Which rules it's breaking?
Yes, but what are the rules? There's something we need to know. Tell me something.
F of A.
Okay, right. So what we need to know is f of what?
-1.
-1 is equal to what?
-2.
-2. Okay.
So F of A is defined, so it doesn't break that rule.
Right. It is defined. Okay, it is defined. Okay, but how about this?
F of A is still defined.
Okay, so let's say this is 3. Okay, Chase, you tell me some things about this related to limits and continuity and things like that. And so sort of do like Will and just start somewhere and tell me something.
So the limit of f of x as x goes to 3 from the negative.
Does that help?
Yes.
It's equal to?
Is that 5? Or would it be the
Well, tell me what the limit is.
1, 2, 3, 4?
Okay, it's what?
4.
Okay, now tell me something else.
Limit of f of x as x goes to 3 from the right equals 4.
Okay, tell me something else.
Limit of f of x as x goes to 3 equals 4.
Yes, okay. So the limit exists. Now tell me something completely different than limits that's important for this problem.
How do I?
F of 3.
F of
Okay.
3 is equal to what?
5.
Okay, f of 3 is equal to 5. So does the limit exist? Is it continuous? No. Why is it not continuous?
There's a hole.
Right, there's a hole, but the way we would say it is because f of a does not, f of a exists,
But it does
but
not.
f of a does not equal the limit as x approaches a of f of x, right? Because it's coming to this point, but f of a is actually that point. So it is not continuous. It is discontinuous, okay? Okay. Now on the problem, there's a lot of things like this. Okay. Okay. Now, the thing to pay attention here is that if I ask you for the limit as x approaches 1 of f of x, what is really, really important for you to do when you work this problem, Victor?
Solve it from the left and the right.
Okay, but yes, but you're right. You solve it from the left and the right, but you got to make sure that you got to focus where?
On the where one.
On this one, right? Because you see how there's all this other distraction in there. Does that matter as far as what's happening at 1? No. So make sure that you're looking right where you're supposed to be looking, okay? Because there might be more stuff going on. There might be several questions associated with one graph, and so make sure that you look at where you're looking at. I mean, at where it's pointing you to. Okay, so there's a lot of problems like this. Or I might just say, also like I might say, what is the limit as x approaches -1 of f of x? Okay, Noah, how would you answer that?
So you want to focus on -1.
Yes.
But you're coming from the right.
Right.
So then you follow the line from 0 to -1 from the right. So then it equals 1.
Yes. Okay. So you've got to pay attention. This, what you have to see for this one, the limit of f of x as x goes to -1 from the left, the limit as x goes to -1 from the right, the limit as x goes to -1 of f of x, f of x, f of x. Those are all different, right? So you've got to pay attention to the little pluses and minuses. And so I look at you, Victor, because sometimes you rush these things. Make sure that you're looking very carefully at what I'm asking, okay? Because sometimes you just, you're just smart. You think real fast, and sometimes you don't see that little bitty there's a plus, and you got to see that it's asking for something specific, okay? Okay, these are a lot of things where you look at a graph, okay? So if I say to find a limit graphically and numerically, how would you do that?
So graphically,
yeah, and you would probably, in this, when you're doing rational equations, Excel is not the best way to do it, right? Because, the problem with Excel is if you have something like an asymptote, what you guys do is you come and then you just plot the whole thing and you get something like that, and you're not really seeing the asymptotic behavior. If you have a rational function, you need to sort of do it like if I have the limit as x goes to 5 of x squared minus 25 over x plus 5. How would you do that, Victor?
I would use a table first, or write a table.
Yeah, so this is a what? What kind of function is this? It's rational, right? And this would not be something to try to do in Excel. So what is the most important rule of calculus?
Algebra before math.
Algebra before math. Did you really say that? Algebra before math? Okay. So what would be the algebra that you would do, Victor?
X minus 5 and x plus 5.
Okay. So then it's x minus 5, x plus 5 over what?
X plus 5.
X plus 5. Now, Victor, what do I do?
You know that x cannot be equal to -5.
Right, but I say limit as x goes to 5 of what?
X minus 5.
X minus 5. Okay. So what do I have to write here?
X cannot be equal to -5.
X cannot be equal to -5. The limit of x goes to 5. Now, at this point, what would I do? That's the limit as x goes to 5 of what? X minus
limit is x goes to 5 of 5.
minus 5. Okay, yeah, no, 5. You're right. You're right. The negative's out front. Okay, so what would this be?
5 minus 5
is equal to
0.
And you remind yourself x cannot be equal to -5. Okay?
Are we going to be able to use our notes that we took?
Yeah,
about the
so
rules?
I guess that's a
No,
good question.
you got to know. You got
So
to
the
know.
rules, we just got to know the
You got to know the rules.
Okay.
Okay. So you got to know how to do that. Algebra before calculus. Okay. And if I say graphical and numerical, you know, you got to decide, should you use Excel or should you just try to do it in a table? Okay. And if I say, okay, Noah, if I say identify all of the discontinuities, what would you say? How would you answer that?
At x equals 2.
Yes, okay. Yes, listen to what he said, at x equal 2. If I'm asking you where there's a discontinuity, you need to tell me the what? The where, and the where is the x value. Okay. At x equal 2,
There is a whole discontinuity.
there is a point discontinuity. Okay. What else would you say, Will?
That. What's the middle one? What number?
7.
7. Huh?
At x equals 7, there is a
What happens when you get there? It what's?
jumps up,
Yeah, it's a what discontinuity?
jump.
Jump. And then what would I say else, Franklin?
At x equal
10. Let's say.
10, there is a asymptote.
An asymptote discontinuity. Okay. Does everybody understand that? Right. So you've got to answer it. You just can't like point at the graph and like would this be the right answer? Like this. No. You got to answer it like this. Okay? So there's a whole bunch like that, and so you don't want to miss that.
Will there
Okay.
be a bonus?
No, there is no bonus on this. I'm sorry. Okay.
How many questions are we running?
21. Okay, if I have x squared plus 49, or x squared minus 49 over x plus 7, okay, and I was going to ask you where are the horizontal and where are the vertical asymptotes? Let's do the vertical asymptotes first. Noah, what would you do?
I would split up the top one.
But tell me what you're doing.
So,
Say it, Will.
Algebra before calculus.
Okay, I want you to say that because I want you to always have in your mind algebra before calculus. So what you said was not wrong, but I want you to always say algebra before calculus. So what do I do, Noah?
so x plus 7 and x minus 7 over x plus 7 and x minus 3.
Okay, now I want you to tell me what happens. What am I going to do?
So that x plus 7 on top and x plus 7 on bottom equal 1.
F of x is equal to then what?
X minus 7 over x minus 3.
But now tell
as
me-
x cannot equal -7.
X cannot equal to -7. But now what you have to, this is so important because I don't think everyone understood this on the homework. What happens when you take a term out? What happens on the graph? Do you have a vertical asymptote? No. You have a what?
Point.
You have a hole. You have a point that's missing. And so whatever the graph looks like, at -7, you have an open hole. When a term is removed, it does not make an asymptote. Is there a vertical asymptote? Where?
X
X
minus
minus
3.
3.
And so where?
3.
X equals 3. Okay, that's the vertical asymptote. Now, Emily, how do you find the horizontal asymptote?
When x gets really, or y, yeah, x gets really big.
Okay, and so it would probably be good to do it where? After the algebra. And what happens here, Emily, when x gets really, really big?
It's 1.
Yes, so it's what is 1?
The
Or-
horizontal asymptote goes to 1.
Okay, but don't say, okay, horizontal asymptote, yes, 1, yes, but you need to say it how the horizontal asymptote is what?
Y equals 1.
Y equals 1. Is that understood? Okay. Because if you just say 1, I don't know, maybe you're thinking that's a horizontal asymptote. If you say 1, I don't know if you know what a horizontal asymptote is. I'm not cracking at you, I'm just saying it so that everyone understands how they need to write their answers. Okay?
Is that how we're gonna have to write our answers on the test?
Yes.
Okay.
And some of these are multiple choice and some of them are not multiple choice, so. Okay,
Are you done?
Is cut.
yes.